I apologize for being late. I was teaching until 8:15, and so just running over after a class. I'm going to very quickly talk about a series of projects that have to do with seismology. And let me jump right in. First of all, I want to acknowledge that everything I do is collaborative. So all projects, just as in the other presentations you've heard tonight, I've had the great fortune to work with some fantastic designers, filmmakers, artists, seismologists, and engineers. This is the kind of thing we do by day. This is our bread and butter, which is robotics. We do a lot of work on algorithms for manipulating three-dimensional objects. We try and understand the structure, the mechanics of grasping and manipulating, and we apply that to things like surgery and manufacturing. But that's not what I'm going to talk about. Another passion of mine has been I've been unable to contain for 30-some years is that I'm really interested in art, and I'm particularly interested in the intersection of the digital to the natural world, when those two things come together, and what kind of tensions and frictions arise in that juxtaposition. So I'll talk about these projects that I'll call companion works. They're all related, and you'll see why. But this comes right up until very recently. This is a brand new project that we're still fine-tuning. This is a shot. Anybody know what that is? That's the
City Hall.
City Hall. Yeah, 1906. So that's the result of the big one, the big earthquake in San Francisco. And when I moved to California, I asked everybody, "What do you have on your earthquake kit?" And basically people would say, "What do you? I don't have one." And I'd be like, "What?" And now I've been here for 20 years, and I don't have an earthquake. So I get it. We just don't want to talk about this stuff. So one of the things I'm interested in is like trying to remind and just make people aware of this thing that's under us, this sort of the precipice that we live on. Particularly, we're sitting, as you probably all know, right over the Hayward Fault. Like a major fault line is right here, a few hundred yards from here. So Memento Mori was the name of the very first project. In 1997, I was here at Berkeley, and I found people in the seismology department who kindly agreed to let us have access to the feed, the live feed of the signal. And we used that to generate a very, we started thinking about it in the context of an earthwork, like Spiral Jetty by Smithson. You may know Lightning Field. I love these works from the 60s where we're really connecting to the physical earth in some way. So I wanted to do that in a digital context. So the Seismology Lab here is fantastic. It's one of the world leaders. And they have a detector right here on campus in Strawberry Creek that basically reads out samples at, Sanjay knows the frequency?
30 hertz.
30 hertz, okay. And streams that up all the time. It's constantly recording. And they graciously allowed us to have access to it. There was a whole discussion about respecting the data. It was very important. And then we built this. We called it Memento Mori, and you probably all recognize that's the Latin for reminder of mortality. And so we built this thing. This just looks like this. Really simple, just a monochrome trace that was moving in response to the z coordinate, the z velocity of the seismometer. And when we first showed it to the seismologists, they said, "Well, wait, where's the axes? We have to. What's the scale? And we're like, no, it's just an artwork. It's just meant to evoke the idea of the Earth as kind of like an EKG or something, like some kind of heartbeat." And this is still online. You can. It's online. Some people use it as a screensaver or something. It's very mellow. But then when we put that out in '97, shortly thereafter, a composer approached me, Randall Packard, and he said, "What about connecting that to sound?" And so we worked on MaxMSP. The signal is too low frequency, so if you just listen to the sound, you plug it into the speaker, you don't hear anything. It's just low frequencies. But you can use it to essentially sonify that sound by using it as essentially a trigger. It's going to conduct other sounds. So you pre-store banks of sounds, and then use that to drive an audible signal. So we built this thing we called Mori, and the reason is that it turned out we had an invitation to go to do an installation in Tokyo. And the Mori in Tokyo means, in Japanese, means forest sanctuary, nature. So we sort of like that, so we dropped the Memento part and just called it Mori. And we built this acoustic installation, and you can walk in, it was about 15 feet by 15 feet, and you would essentially be surrounded by the sound of the earth. And the idea was to essentially be immersed. And you would look down here, and there was, well, there were a lot of elements, wind kind of coming up from fans and stuff, but it was meant to sort of give you the sensation of being inside of it. And the best part was how people would respond. We loved this, that people would just like lay down and kind of just groove on it. And you would really get a sense of being, you know, that was the idea. It's like, what would it be like to go deep into the earth? All right, then that toured around the country, actually, and was shown in 8 different galleries and museums. And then as we got closer to the anniversary of the 1906 earthquake, I had this idea in my mind of doing something with that same idea, but sort of for somehow to commemorate the 1906. And I happened to sit at a dinner next to a dancer from the San Francisco Ballet. It was Muriel Maffray, who was actually the principal dancer of the ballet at the time. And I was just seated next to her by luck. And after a few glasses of wine, I said, would you ever dance to the sound of the earth? And I don't know, she must have had some wine too. She said, of course. But you realize that for a ballet dancer, everything is very controlled, very rehearsed. Everything is very, very precise. And what I was asking her to do was essentially improv, because you just don't know what the earth is going to do. But I give her huge credit. She was very brave. She actually convinced Helgi Tomasson to let us do this at the Opera House. And we did it almost to the day, 100-year anniversary of the 1906. And so we did it on the full stage at the ballet. She danced it. She's spectacular. I'm going to just try. I don't know if the sound will work in here. Did you try sound at all? I plugged in. Oh, with those things? Maybe. Let's just see.
That's the power.
Oh, that's the power. You need the power too? Okay. Let's see what happens if this will work. If not, it's not a big deal, but I could give you a little sample, just a very short clip of what. Oh, I took that out. Okay, so I'll just go like that. Because we're in the Opera House, and we don't know if everything's going to work or what the Earth is going to do. And we tried it earlier in the day, and the Earth was very quiet, so we kept cranking up the volume, cranking up the gain on the thing. And at some point, it was shaking the chandeliers. So when we went live at 8 p.m. when she went on, we didn't know what was going to happen. And fortunately, there was just a very good moment. The Earth cooperated. She did this fantastic thing. Anyway, it goes on for a little bit. I'll stop it here, but what happened at the very end, I just have to tell you, is that everybody was so happy. I was so relieved that it worked. That we went out, and she took a bow, and then she called us over, who had worked on it, and in front of 3,000 people, I didn't know what to do. I just totally wasn't prepared, but I looked over at her, and so I curtsied. Like that, in front of all these people. They were all like, they're supposed to bow. So, anyway. Then, in 2013, it was, I had read about the death of one of my favorite artists, Kenneth Noland. And at this point, started thinking about it more in a different way. This was about, now, almost 20 years after the original project. And I was just thinking about mortality in a different way. And I can say more about that. But rather than seeing it as a dark and kind of morbid kind of thing, I started thinking, well, it's going back to the Earth. It's about something more celebratory. So I worked with Sanjay and also 2 wonderful designers who are now at Google. And we did a tribute to Kenneth Noland. Those are the kind of paintings he does. And a lot of them are like these bullseye paintings, but beautifully colored. We worked with the Nevada Museum of Art in this to build this, and this is what it looks like. It's a different kind of display. So rather than just that monochrome trace, it's these what we call blooms, meant to evoke flowers. And the idea of is also, it's again a reminder of mortality. It's Earth, pushing up flowers. But and they're also kind of a little bit similar to like those epicenter plots that you see. But what's interesting is that colors are constantly evolving, the mixture of colors. And Sanjay worked on this. He did some beautiful coding for it. It just runs, and so we've done it as installation in the museum where it's just in a room playing. This is what it looks like. Everybody asked what happens if there's an earthquake. So we played back the Lobo Prieta earthquake through the system. That's what it would look like. Kind of just a lot of activity coming on at the same time.
So this too is driven by the sensor here and working.
Yeah. So what we did is we replayed. We had the data set from the 97. So we were able to play that back. And we can start to talk about the data set. We're basically, it's streaming out. We're filtering it to do a little bit of low-pass filtering. Then we plot the blooms. They're, basically we're looking for a zero crossing in the first derivative of the z velocity, and that generates a bloom with this radius at a particular location depending on the second derivative. And then the colors are pretty much random. They just pull those from image files that, well, in this case, were from flowers, images of flowers. So this is another shot that, actually, do you remember how this worked, what this was?
I believe they gave us the Solomon Islands, because we would, the story behind this is that we went to this, I think this was presented in front of the seismology department, right?
Right, that's it.
And so they wanted to know what happens during an earthquake, could they interpret anything? So we, at the top, I think it was the replaying, at that time it was the most recent earthquake was something in the Solomon Islands, and then we showed them the.
Yeah, Sanjay mocked this up and put this together. It's beautiful because you can actually see, the seismologists wanted to see what does the signal look like because they wanted to see, compare to look at it. They really like it. They still have it on their website, and it's online 24 hours a day. So it's still playing. Anytime you can go in and check it out, you see a lot of variation. And the question is, can you read it? It's interesting because the signal like this is not typically that interesting to seismologists. They look for when there's a big event, then they really study. But can you have this kind of a background, and can you kind of learn to interpret or read it? We think of it as more, as an artwork. It's really a suggestive to give you a sort of. Actually, someone in a museum had this was sitting there. They installed a couch. It was on this big screen in a sort of video room, and they were sitting in there and. Says something. I feel like I'm just kind of kicking back, watching the waves, and we're like, well, actually, you are. That's exactly what you're doing because these are waves. So, so this is a photo of Fernanda Martin. They've done amazing other projects. I just want to give them credit. This is the one that they're most famous for. You may know the wind map. Fabulous piece that actually takes live data from the weather forecasting, or weather measurements, and then generates these kind of displays, and also real time, and those are available online. Yeah, we did it with the museum. They actually acquired the piece, so it's now part of their permanent collection. And now the last thing I'll just leave you with, and would I have a minute left or so? Something?
5 minutes.
Okay, well, this is called Wow and Flutter, and that's a name of an artwork. One of Kenneth Noland's paintings was called Wow and Flutter, and we like that name. So we've taken this little in a slightly different direction, and Yiming is back here, played a crucial role. He's got a clean shirt on tonight. He said, should I get dressed up? And I was like, no, it's okay. But so here, the idea is to make the version that's mobile friendly. So all the versions I've talked about would run on a laptop or desktop machine. And they actually push the boundary a little bit of what you can display, because you actually have to generate these images in real time. So we went back and I basically asked Sanjay and Yiming to see, well, could we make this run on like a phone? What can we do? Now, it turned out that just the display, vector graphics being able to do the full blooms was hard. So then we started thinking maybe rings. There's less real estate. So they use these tools that they can answer more questions about. But I'll show you what the result is. But then once we started thinking of rings, then this other metaphor came to mind, which is sort of the ripples of water and droplets. And there's a lot of interesting physics there. Quite a bit actually there's a number of papers on the physics of droplets. So we started playing with that. So it's similar, you'll see in a second what it looks like, but it's similar structure, but now rather than just growing large as a solid bloom with concentric rings, it's going to look more like droplets. And again, to evoke nature. And the color palette, we tried a bunch of things, but we ended up with this Kandinsky painting. He's a superb colorist. So we went to that. We tried some Kenneth Nolan's, but they don't have enough variation. So this one is what we pull from. So I'll show you what it looks like. Hope it's going to, yeah. Well, actually, there's quite a bit of activity right now. Holy cow, let's get out of here. That's a little more than normal.
Screen size.
Oh, the screen is too low.
It's an earthquake-safe building, so we're okay.
Carlo designed it, so we're all right. Interesting. So there's a lot of sort of knobs you can tweak in terms of gains and things like that. That's a little busier than normal. I will say one thing that we have found is that sometimes at night they do construction up on the way up to LBL, and that picks up. It triggers on the.
It's a Cal band playing just in a stadium. That's what makes it.
Oh, yeah, Cal band. Actually, I was going to say if someone's at Greek theater, that would probably do it too. But you get the idea. So we're still fine-tuning. There's a lot of parameters just getting it. It's not quite where we want it yet, because we really want it to look like just rain, droplets of rain. But we're trying again to play with this sort of analogy where we're taking a data signal that's really from a natural source. So it's a truly random. Well, actually, you could argue we could talk about that because it's not random in a sense. It's actually very directly derived from motion in the Earth and physical motion. It's unpredictable. It's truly unpredictable. And there's a lot of information in some way behind these behind this signal. It's very important to us because obviously if we could read it, if we could anticipate it, we'd be able to predict. But we can't. So, so that's an image. And I'll just do a quick mention, as Piero said. The ATC is another series that's also that's in the same spirit as Laser. So it's something I invite you to. It's you can just go to that website. There's talks about once a month. It's different in flavor, and I actually really have to say I've grown to really appreciate Piero's model because he has 4 short talks per event, and we do 1 long talk, which is sometimes good, sometimes not so good. Depends. Carlo knows, he could do a bunch of them. But now on to the last thing I'll just mention is that tomorrow, as it turns out, we're doing an event that's related to this. It's called a Wake Up Call for California, and we're presenting 5 speakers who are all working on different technologies for alerting and awareness about earthquakes. So one of them is the Seismology Lab is developing something called Shake Alert that you might have heard, but this is ideas that you'll get a warning up to 30 to 60 seconds before an earthquake. It will basically trigger your cell phone if you have the app. So that's under development, but they're going to be talking about that and some other tools like that will give you can go type in your zip code and it'll tell you all kinds of information about your vulnerabilities. So this is tomorrow, 1 to 3 p.m. Over in the Citrus Auditorium. So I invite you to come to that. Thank you.